In a revealing announcement that could forever alter our place in the cosmos, NASA has reported the detection of a possible extraterrestrial signal originating from the direction of Proxima B, the closest known exoplanet to Earth. Located just over 4 light-years away, Proxima B orbits within the habitable zone of its star, Proxima Centauri, making this revelation one of the most significant in recent astronomical history. This extraordinary discovery has sparked a global wave of curiosity, excitement, and wonder. Could this finally be the moment when humanity confirms that we are not alone in the universe? The road to this monumental moment began with years of careful observation by NASA's most advanced telescopes and data analysis centers. These instruments have been scanning distant stars and planetary systems for subtle signs of life, communication, or unusual behavior. Among these, Proxima B has long stood out as one of the most promising candidates. Its Earth-like size, rocky surface, and position within its star's habitable zone made it a top priority for astrobiologists and SETI researchers alike. The detected signal is unique. Unlike anything ever recorded, it is not a random burst or a common cosmic phenomenon. Instead, it carries a distinct, structured repetition, something that strongly suggests an intelligent origin rather than a natural one. It may represent a new turning point in the search for extraterrestrial intelligence. The implications of this are vast and deep. First and foremost, it validates the long-held scientific belief that life, perhaps even intelligent life, might emerge under similar conditions found on Earth. Second, it provokes new questions about the nature of such life. Could it be microbial, or are we detecting a civilization far more advanced than our own, one capable of sending interstellar messages across light years? NASA scientists, in collaboration with research teams from around the globe, are now meticulously analyzing the signal. Their task? Deciphering its patterns and attempting to interpret any meaning embedded within. Is it a greeting? A beacon? A warning? Or something beyond human comprehension? This event has captivated more than just the scientific community. Discussions have spilled into social media, political forums, news networks, and living rooms. People across the globe are now gazing up at the stars, contemplating what, or who, might be looking back. Are they peaceful explorers or unaware of our existence? Do they resemble us, or are they beyond imagination in both form and culture? Even as speculation grows, so do more profound questions. What does this mean for humanity? How should we respond if we confirm that the signal came from intelligent extraterrestrials? What kind of diplomatic protocol do we follow? Should we attempt to answer? Or should we remain silent and observe? The philosophical and ethical implications are equally enormous. How would this reshape our understanding of religion, human identity, or even the definition of life? If we are no longer alone, then what role do we play in a larger cosmic community? Despite the enthusiasm, leading scientists emphasize caution. The verification process is ongoing, with every possibility being considered, including natural or technological interference from Earth. False positives are not uncommon in radio astronomy. That's why NASA and its partners are proceeding with painstaking care, triple-checking their data, and avoiding premature conclusions. Still, we are possibly standing on the precipice of the greatest discovery in human history. For now, the world waits, curious, hopeful, and perhaps a little anxious. This signal, believed to originate from Proxima B, adds urgency to our ongoing efforts to explore the cosmos. Proxima Centauri, located 4.37 light-years from Earth, is part of a triple star system that also includes Alpha Centauri A and B. These two stars are more similar to our Sun in temperature and brightness, while Proxima Centauri is a dim red dwarf. Proxima B, the exoplanet in question, was discovered in 2016 and has remained a key focus due to its size and potentially habitable conditions. In April 2019, the Breakthrough Listen initiative, a project backed by over $100 million in funding and aimed at finding signs of intelligent life, recorded a narrowband radio signal while using the Parkes Radio Telescope in New South Wales, Australia. The signal, later designated Breakthrough Listen Candidate 1, or BLC-1, was isolated from nearly 4 million other signals collected during the campaign. For such a signal to be taken seriously, it must meet two critical criteria. First, it should occupy a very narrow range of frequencies, something rarely produced by natural astrophysical phenomena. Second, it should exhibit Doppler shifting in frequency, consistent with the motion of a planet like Proxima B in relation to Earth. The BLC-1 signal met both criteria. Scientists painstakingly filtered through the data, eliminating interference from Earth-based sources. Eventually, one signal stood out, highly focused, consistent, and unexplained. It was only present when the telescope was pointed directly at Proxima Centauri and remained detectable for a total of 30 hours over multiple observations. Further analysis linked this signal to Proxima B. The planet, although close to its star at just 0.05 astronomical units, receives about 60% of the solar radiation that Earth receives due to its star being cooler and dimmer. With a radius 1.1 times that of Earth and a mass 1.3 times greater, Proxima B is a rocky planet with similar density, making it, in many ways, a near twin to our own world. However, it differs in crucial ways. Proxima B is likely tidally locked, meaning one side permanently faces its star while the other remains in darkness. This could result in extreme climate variations, but it doesn't rule out habitability. There could be a narrow, twilight zone, between the two hemispheres with more temperate conditions, ideal for life. Beyond Proxima B, humanity has now catalogued more than 5,000 exoplanets, with NASA adding 65 new ones as recently as March 21 of this year. These discoveries are reshaping our understanding of planetary formation and the frequency of Earth-like worlds. Among these planets, Kepler 1649c stands out. Found in 2020, it is remarkably Earth-like in temperature and size, orbiting a red dwarf star in its own habitable zone. With each discovery, the odds of finding life somewhere out there become more favorable. At the heart of this planetary gold rush is the James Webb Space Telescope, JWST, the most advanced telescope ever created. With 100 times the power of its predecessor, JWST can peer into the atmospheres of exoplanets, detect signs of water, carbon dioxide, and even organic molecules, all essential components for life. JWST's infrared capabilities are a game-changer. Unlike visible light, infrared waves can penetrate the thick clouds of dust and gas that obscure newborn stars and planets. It also detects heat signatures, revealing planets even when they are too dark to be seen with traditional telescopes. This allows scientists to observe planetary systems at every stage of development, from infancy to maturity. One of JWST's key goals is to determine whether rocky planets in other solar systems have water and possibly biosignatures. The telescope's MIRI, mid-infrared instrument, is specifically designed to search for hot molecular gases near young stars, places where planets like Earth could be forming. By examining the earliest stages of star and planet formation, JWST will help answer some of humanity's biggest questions. How do planets form? What conditions allow for life to emerge? And most importantly, are we alone? The answers may already be echoing through the cosmos, carried on beams of invisible light across vast distances. Perhaps, one day soon, we will listen closely enough, and understand. Until then, the signal from Proxima B stands as a beacon of possibility. Whether it turns out to be a message, a clue, or a cosmic coincidence, it has already reignited humanity's deepest curiosity. The universe just became a little more mysterious, and far more exciting.